Hello student, I am Nirmala Morade, Assistant Professor, Department of Mathematics from S.V.K.T College, Devali Camp, Nasik. Today's lecture's topic is Range and Standard Deviation. It is from Unit 4, Measures of Dispersion. So let us recall the previous lecture. If you remember, in last lecture, we studied about the geometric mean, harmonic mean and the related examples. So if you consider the geometric mean of two numbers, it is the square root of the product a into b. That is, if a and b are the two numbers, then its geometrical mean is same as a into b raised to half. So now we generalize this concept for the n numbers. Suppose the numbers are x1, x2 up to xn. Then the geometric mean of this series is the nth root of x1 or nth root of the product x1 to xn. That is, geometric mean of the series x1, x2, xn is same as x1 into x2 into x3 up to xn bracket raised to 1 by n. So this is a definition for the simple series. Suppose we have to given the observations x1, x2, xn with the frequency f1, f2, fn respectively. Then the formula for the geometric mean is x1 raised to f1 into x2 raised to f2 up to xn raised to fn whole bracket raised to 1 upon capital N, where capital N is the total frequencies. That is, capital N equals to f1 plus f2 plus up to fn. Also we studied harmonic mean. So definition of harmonic mean for the two number is twice AB upon A plus B, or it can be written as 2 upon 1 upon A plus 1 upon B. Similarly, if we have to given the n numbers x1, x2 up to xn, then the harmonic mean is defined as n upon 1 upon x1 plus 1 upon x2 plus up to 1 upon xn. Also we have to study the relation between geometric mean, harmonic mean and the arithmetic mean and the related examples. So now in today's lecture, we are going to study what is meant by dispersion, its a definition, what is the need of the dispersion, what are the types of dispersion, as well as the range and the coefficient of range. We are going to study another concept, the standard deviation and the related example. So if you remember, okay, so first see what are the learning objective of today's lecture. After completing or after watching this session, you will be able to know the meaning and the need of the measure of dispersion. What is meant by dispersion? What is the need of it in the real life? Also, you will able to distinguish between the absolute and the relative dispersion. These are the two types of the dispersion. One is the absolute dispersion and another one is the relative dispersion. So you should know what is the difference between these two. The third learning objective is you can apply the various measures of dispersion to the given data, and another objective is calculate and compare the different measure of dispersion. So the main aim of this video is you should know what is the meaning and the need of dispersion. This is first primary aim. You should know what is the types of dispersion, what is the difference between them, and where we have to apply the absolute measure and where we have to apply the relative measure. So these are the objective of our today's lecture. So now first we see what is meant by dispersion. So if you remember, in last chapter we have we studied about the measures of central tendency, that is mean, mode, median. We have to study these three types of central tendency. One is mean, another is mode, and the median. So, the measures of central tendency that describes the whole data as a single representative value. But sometimes it is not sufficient to describe the data by using these values. So, for that a further investigation is needed, and that is a dispersion. So, now for that we will see one example. Now see in the table, we have to given first column number of student 1, 2, 3, and there are 3 groups, group 1 X, group Y and group Z, and we have to given suppose the marks. And also at the last row we have to given the means of each group. So, mean of first group is 50, mean of second group is also 50, and third group is also 50. So, we can observe this mean. So, one can say that if the means are same, so all these students are equally capable. But our this conclusion is strongly wrong. Why it is strongly wrong? If you observe carefully here, the group or the observation in group X, the marks in group X are equal to the mean. In second group, the marks are closely equal, close to the mean, but that is not happen in in group Z. The marks are vary from this mean. So, our conclusion just by taking the mean that all these 3 group or all these groups have equal capable is strongly wrong. So, in fact, if we calculate the median for the group X and group Y, you can observe these 2 groups have the same median also. So, in this case we say that just the measure of central tendency is not sufficient to describe the whole data. In sometimes it is fail. So, in that case we consider the dispersion. So, what is the dispersion? Dispersion is nothing but the variation, deviation of the values of the given variables from their mean is the dispersion, and dispersion is useful to understand the data more clearly compared to the measure of central tendency. So, now we see what is the actual definition of the dispersion. So, if you see the meaning of dispersion, it is nothing but the action or the process of distributing some things or peoples over a wide area. This is the meaning of the dispersion in dictionary, or the another meaning is the state of getting dispersed or the spread. Okay? But in statistics actually same definition is there. In statistics, the dispersion is nothing but the deviation or the variation of the different values of a variable from their average. From their average, we can take any type of average here, either mean, mode or median. So, in statistics, the measure of dispersion helps us to interpret the variability of the data. Okay? That is to know how much the data is homogeneous, or how the data is homogeneous or the heterogeneous is. That is, we can say that that data is how much data is the squeeze or the scattered from their mean. Okay. So, this is the definition of the dispersion. Dispersion is nothing but the variation or deviation of the values of the given variables from their average. So, there are 2 types of measures of dispersion. One is the absolute measure of dispersion and another one is the relative measure of dispersion. In absolute measure of dispersion, it has a unit which is same as the unit of the observation. So, since it has a unit and the unit is same as the observation, suppose in case of I want to compare the 2 different types of data or 2 data which having the different units. So, in that case the measure of absolute measure of dispersion is not useful. So in that case we can use the relative measure of dispersion. In relative measure of dispersion, actually it is a unitless. Sometimes or commonly it is calculated in percentage. So to comparison of two data having the different units, we can use the relative measure of dispersion. So there are four types of each, four types of absolute measure of dispersion and four types of relative measure of dispersion. So what are the four types of relative measure of dispersion? First one is the range, that is very simplest absolute measure of dispersion. Second one is the standard deviation, next is mean deviation, and last one is the quartile deviation. So these are the four types of the absolute measure of dispersion. And there are four types of relative measure of dispersion. So first one is coefficient of range, second is coefficient of variation, coefficient of mean deviation, and coefficient of quartile deviation. So these are the types of relative measure of dispersion. So what is the difference between these two? The first difference is absolute measure of dispersion has a unit and relative measure of dispersion has no unit, it is a unitless. So for comparison of the two different types of data having different limits, we can use the relative measure of dispersion. In that case, the absolute measure of dispersion is not working, is not useful. So in today's lecture actually we will cover these two topics, range and we focus on commonly these two topics, range and the standard deviation. So as already I told you, range is the smallest measure of dispersion, absolute measure of dispersion. It is easy one to calculate, to understand also. So let us see what is the actual definition of the range. So for range, to calculate the range, we require the standard, we first observe or we first write what is the largest observation and what is the smallest observation. So I denote the largest observation L here and the smallest observation as a S. And if we take this one, the range is defined as the largest observation minus the smallest observation of the series. And the coefficient, so here range is the absolute measure of dispersion and the another one is the coefficient of the range. So coefficient of range is defined as the largest observation minus smallest observation divided by largest observation plus smallest observation. So obviously it has a no unit and it is the relative measure of dispersion. So by definition is very easy, you can observe here. So now we know that commonly the data is divided into three types. So commonly if I say that if we have to given just simple observations, simple data, we have to given the observations x1, x2, x3, this is one type. Second, we have to given the ungrouped frequency distribution, that is we have to given the observation and corresponding frequencies. And third type is we have to given group frequency distribution, that is we have to given the classes and their frequency. So according to this, now we will see what are the formulas and how to calculate, not what are the formulas, but how to calculate the range of the given data. So now first simplest example is here. Find the range and the coefficient of the range for the given data. So observe all the observations carefully. Find the smallest as well as the largest observation here. So you can observe here the smallest observation is 5 and the largest is 12, and just take L minus S, so we get the range here. So the range of the given series, given observation is 12 minus 5, which is 7. And similarly you can easily calculate the coefficient of range, which is same as L minus S upon L plus S, which is same as 12 minus 5 upon 12 plus 5. And just do the calculate here 7 upon 17, the answer is 0.412. So okay, use the calculator to find it. So directly if we know the observations, we write the largest and smallest, just put the values, calculate, we will get here range and the coefficient of range. Now another problem is, Find the range and the coefficient of range for the following data. Now here we have to consider the data as a ungrouped frequency distribution. Ungrouped frequency distribution means we have to provide observations and corresponding frequencies. So in that case also we use the same formula. So see, the observations are 5, 10, 15, 20, 25. So you can easily observe here the largest observation is 25, smallest observation is 5, and so L is 25, S is 5. Use again the formula, just put the values and calculate range and the coefficient of range. Now it is very easy to calculate it. It's okay. So now let us consider the next problem. This is the second type of data, ungrouped frequency distribution. If data is represented in terms of group frequency distribution, then see how to calculate the range and coefficient. So this is our third example. We have to given the group frequency distribution. Observe here in this problem the data, or it is a exclusive type of frequency distribution. Exclusive types means there is no gap between the two classes. Observe here, the first class upper limit is 150, and for the next class it's a higher class, the lower limit is 150. That is, classes are continuous without break. That is, it is a exclusive type of frequency distribution. So in this case, the largest observation you can observe here 600 and the smallest is 100. That is, L is 600 and S is 100. Again here use the same formula. Put the range is the difference between, not a difference, it is L minus S, which is 500, and the coefficient of range is L minus S upon L plus S. The difference 600 minus 100 is 500, divided by their addition is 700. Do the calculations. So output is here 0.71543. So for this data also it is easy to calculate the range as well as the coefficient of variation. So just remember for the next case, it is very important. If the classes are not continuous, that is for group frequency distribution, and the type is inclusive type. Inclusive type means the upper limit of the previous class is not same as the lower limit of the next class. So now see, if you observe class 1 and 2, there is a gap of 1 unit. So upper limit of the first class is 154 and the lower limit of its next class is 155. So there is a gap between the numbers or the limits. So this is the exclusive type of classification. So in this case, we have to find class boundaries first and then write the largest and the smallest observation. So now here, if you observe here, all the that is, these classes have the equal width. The width is same. So now if I consider the class 1 and class 2, and the difference between the lower limit of the first class and the upper limit of next class is 1. That is 155 minus 154. The answer is 1 here. That is, to find the class boundaries, we should first find the gap between the two classes, and here the gap is 1 unit. So take its half, half is 0.5, and as we know, to find the class boundaries, we have to subtract 0.5 from the lower limit of the class and add 0.5 to the upper limit of the class. And that is why I just consider here largest observation. The largest observation is 174, and now since I want its class boundary, so I should add the 0.5 here. So largest L is 174 plus 0.5, so it becomes 174.5. And for smallest observation is 150, but classes are not continuous, and that is why I subtract, to find the class boundary, I subtract 0.5 here. So 150 minus 0.5, output is 149.45. So remember, in this case, if classes are not continuous, there is a break. So in that case, that is in inclusive type of frequency distribution, we should find the gap, or we should find the class boundaries, and then we consider the upper class boundary of the last class as a L, and S as, that is smallest observation, as a lowest class boundary or lower class boundary of the first class. So then formula again remains the same. Here largest is 174.5 and the smallest is 149.5. Take the difference, so we will get here range, which is 25, and the coefficient of range is L minus S upon L plus S. Put the values, calculated, so we will get the answer here. Okay. So now just remember which type of data we have to given according to write L, write S, and then using the formula you can easily calculate what is the range and the coefficient of the range. Okay. So as we know that every statistical quantity has its own demerit and merit, similar as a mean, mode, median. So range also has some merit and demerit. So now first we have to write what are the merits of the range. So you can easily observe that the range is nothing but L minus S. So we can easily write what is the largest observation of the data, what is the smallest observation data, and L minus S gives the range. So it is very easy to understand, easy to calculate also. So these are the two merits of this, and another merit is it is rigidly defined. This number or range is rigidly defined. So but it has some demerit also. So what are that demerits? If we observe or if you write definition of range carefully, so automatically you can understand what are the demerits of the classes. So first demerit of this is by definition the largest observation minus smallest observation is the range of the given series or the given data. That is this only depends on the two observation, the largest one and the smallest one. That is, it is not depends on all the observations of the given series. This is one demerit of the range. So another demerit is unduly affected by the extreme values. Since it is depends on extreme values, so this is another demerit of the range. So another demerit is if we change the data, suppose we have to given the data and suppose we want to change the data or the data is changed which is not related the minimum and maximum observation, it will not affect the value of the range, because it is totally depends on the largest and the smallest observation, not the middle one. So this is another demerit of the data. That is, if I consider two series having the same smallest and largest observation and middle part is totally different, then also they have the same range. So using just range, I can't interpret anything about these two types of series. And secondly, since it requires smallest and the highest observation, and suppose we have to given the open-end classes, so in that case we can't calculate the range of the given distribution or the given data. So now since these are the some merits and demerits of the range, so now we see where this range is applicable. So if you remember some medical reports, suppose we consider the report of hemoglobin, maybe anything, suppose we have to given the sugar level, that is always written in terms of maximum and minimum. We have to given the range, and within that range if our output is there, so the report is normal, otherwise we require some treatment. So in that case we use the range. So now first in a statistical, there is a branch of statistical which is known as a statistical quality control. In this branch the range is commonly useful. Second, changes in the prices of shares. In share prices they always observe what is the maximum and minimum, and so in this case also the there is a application of the range. Also in case of temperature. So if we observe in a forecast, the temperature is always measured. What is the minimum temperature of the day and what is the maximum temperature of the day. That is, in this case also the range is used, and already I told you, in case of medical field many reports are depending on this range. We have to given what is the normal range, and so in field of, suppose I want to measure the, always measure the lower limit of the blood pressure and higher limit. What is the higher limit of the blood pressure? Similarly, in case of the other medical quantities, the range is applicable. So I have to mention some of these applications here. Okay, so our next concept is the standard deviation. So as we know that there are two types of dispersion. The first one is absolute dispersion, absolute measure of dispersion, and the relative measure of dispersion. So actually in first year Bcom, we have only these two, the range and the standard deviation. So this is our second absolute measure of dispersion, that is known as the standard deviation, or that is standard deviation. So now first we see what is the definition of standard deviation. So standard deviation is defined as the positive square root of the mean of the squares of the deviation from the mean. See, definition is very easy. Directly if you write the formula, you can write that in terms of words. So we will get the definition of standard deviation. So standard deviation is the positive square root of the mean of the squares of the deviation from the mean. So okay, see, its notation, actually standard deviation is denoted by the small sigma. Okay. So now we write this definition in terms of mathematical formula. So for that, suppose we have to given the observation x1, x2 up to xn, then let denote the x bar as the arithmetic mean of the given series. So according to the above definition, the standard deviation, sometimes it may be written in this form, s dot d. I have to written here another symbol, sigma suffix x. What it interpret? Sigma is the notation for standard deviation and x denotes the observations here. So for suppose the first series is denoted by x1, x2, xn, and so to denote the standard deviation for that series, we use the notation sigma x. So according to the definition, sigma x can be written as positive square root of the mean of the squares of the deviation from the mean. So that is, first I have to calculate deviations of all the observations from mean, that is the x1 minus xi, x2 minus x2 and so on. Take their squares and take their arithmetic mean, and the arithmetic mean of these deviations or square of deviations is its positive square root is known as a standard deviation. In short, this formula can be written as, since we have to consider the sum of these n squares, so it can be written as positive square root of summation of x minus x bar bracket square upon n. Instead of xi, you can just write x also. So remember, this is a formula for the standard deviation if the observations are x1 to xn and the arithmetic mean is x bar. So now we write the same formula in different form. So for that we derive the another simplest form of the standard deviation. So now for again consider definition of standard deviation, sigma x. Now first we write the square of xi minus x bar. So square of x bar minus xi is xi square, that is square of first number, minus 2 times their product, that is xi into x bar, plus x bar square. Now put this value here. So okay, I just simplify the bracket here. Second one is I separate the sum here. So sum of first number minus as we know that here sum is varies from I to n. It depends on the number of observations. Arithmetic mean is a fixed number. 2 is also fixed number. And this sum is varies from I is varies from 1 to n. I have to not written, but I is always varies from 1 to n here. So I just separate this sum here, and since 2 into xi is a fixed number, so the second term is here minus 2 times x bar into summation of xi plus again x bar square is a fixed number, summation of 1. If there is nothing means 1 is remaining there, divided by n. Now we separate the denominator here. After separating denominator, we will get such type of relation. I just separate the denominator n here. So I keep the first term as it is. Observe the second term here. Second term is twice x bar is fixed. Summation of xi upon n is nothing but the mean. So denoted by x bar. So second term becomes 2 times x bar into x bar, that is 2 times x bar square. And the last term is here x square by n as it is, but summation of 1. How many times? I is running from 1 to n. That is, we have to added 1 n times. So output is n. So that n gets cancelled. So third or the last term is only x bar square here. So I have to return all these things. So n gets cancelled. Now combine the last two terms. So the output of the last two term is minus x bar square. So this is our new formula for the standard deviation. So standard deviation equals to positive square root of summation of xi square upon n minus x bar square. So either we can write the first formula which is given in the first line, or you can use the formula which is given in the last line here. So you can use both, anyone, both are easy to understand as well as the calculator. So for the calculation both are simplest one. Okay. So now these are the formulas for the standard deviation. Okay. So now we have to write all these formulas for the simple series. So what happen if we have to given the frequency distribution? We know that there are two types, either group or ungroup, but remember one formula for ungroup frequency distribution. So here remember I have to written in first observations are given x1 to xn, then these are the two formulas to calculate the standard deviation. Now suppose we have to given the frequency distributions. So suppose we have to given the observation x1 to xn with their frequency f1, f2 up to fn respectively. So in this case, what are the standard deviation? So this is the formula for standard deviation. We easily generalize the above formula here. So the standard deviation is same as positive square root of summation of f times in bracket xi minus x bar square upon summation of f. And if you apply the formula, simplify it, that is just squaring the term xi minus x bar square, simplify it, cancel the common term. So the output is here again SD equals to summation of f into xi square upon summation of f minus x bar square. So remember both the formulae in case of discrete data or in case of frequency distribution. So we know that commonly we write or we represent the statistical data in three forms. First, just the observation with one frequency. Second, observations with the frequency f1, f2, fn. And third, classification with classes. Classes are given and frequencies are given. So suppose in case of classes are given, then we take x1, x2, x3 as a midpoint of the corresponding classes. So this is one change, and remember, in case of group frequency distribution, xi is the mid value of the ith class, and calculate mid value of each class and use the same formula here. So remember, there are only two formulas to calculate the standard deviation of the given series or given data. So our next term is variance. What is meant by variance? So variance is nothing but the square of standard deviation, that is sigma square. So automatically sigma is, or the standard deviation is, the positive square root of variance here. So next formula is the relative measure. This is the second relative measure of the dispersion. Coefficient of variation. It is denoted by C dot V dot, and it is defined as the ratio of or it is defined as standard deviation upon absolute value of the mean into 100. So, it is calculated in terms of the percentage. That is the same as sigma upon mod of x bar into 100. Now, first see what is meant by mod. Actually, mod is nothing but the absolute value of a number. Suppose I take the number as a, then its absolute value is denoted by the symbol mod a, and is defined as mod a is equals to a if a is greater than equal 0, and mod a is a minus a if a is less than 0. So, remember, mod a is always a positive quantity. For example, if I take the mod of 2, the output is 2 according to the definition. If the number is positive, its mod is same as itself. If number is 0, its mod is same as itself. If number is negative, its mod is again negative. That is, mod of minus 2 is 2 here. So, in short, it is a quantity which converts the negative number into positive. Okay. Okay, again the same slide is here by mistake, so ignore it. We just consider the next part. So, now consider the examples how to find the standard deviation and the coefficient of variance. So, now suppose the first type of data means we have to given here all the observations, we have to given x1, x2 up to xn. So, now if you remember, I think first you should write the formula. If you write the formula, you can easily calculate the next part. So, I just write here the formula. See the last line say define the formula, or just formula is mentioned here. Standard deviation equals to sigma x equals to summation of positive square root of summation of xi minus x bar bracket square total divided by n. Here n is the number of observations. Okay. So, according to this formula, we have to prepare the rows or the columns. You can write or you can prepare this table in row wise as well as the column wise also. I have to return the here row wise just to for purpose of convenience, that does not matter. You can write vertically also. So, in first row I have to write all the observations, given observations. We have to, so remember what we have to given and what we have to need, that is very important. Here we have to given all the observations x1 to xn. So, I write all the observation in first column, in first row. Next part we have to calculate the mean of the observation. So, we know the formula for the mean. The arithmetic mean is denoted by x bar and is defined as summation of x, sum of all observation upon total number of observation. So, you have to count here how many observations are given. I have to take a simple data and just observe it by taking one look. You can observe here there are 9 observations are given. So, small n equals to 9. So, what are the observation 1 to 9? Now, add all the observations 1 plus 2 plus up to 9. The summation of all observation is 45 here. So, 45, then calculate the mean. Before going to second row, you should know what is x bar, and x bar equals to summation of x upon n. Put summation x equals to 45 upon 9. So, answer is 5. So, here mean of the given data is 5. Now, calculate then second row. The second row is x minus x bar, that is x minus 5, that is from each and every observation you have to subtract 5 and write the corresponding number. So, 1 minus 5 in second column, see here 1 minus 5 is minus 4, 2 minus 5 is minus 3, 3 minus 2 is minus 2, and continue in this way up to the last one. So, in second row we have to calculate x minus x bar. Now, next we require the square of each number. So, now next row is x minus x bar bracket square. So, square of minus 4 is 16. Remember, square of minus 4 is again positive number, square is always positive quantity. Square of minus 3 is 9, square of minus 2 is 4, square of 1 is 1, minus 1 is 1, square of 0 is 0, and continue. Calculate the square of each and every number and write just the below it, and do the sum of all these squares. So here I have to already write the square sum of xi minus x bar bracket square is 60. So now just see the formula, now put the values. This is the formula for standard deviation, square root of sum of x minus x bar square upon n. So by putting the value of summation, that is 60 upon 9, take its positive square root, answer is 2.58. So here remember the formula, and according to you must prepare the tables. So what are the given things? We have to given the observation x1, x2, xn. Write the number of observation. Small n is the number of observation. Here it is 9. Next we have to find its mean. This is the second step to calculate the standard deviation. To find the mean, calculate sum x upon n. So put sum x, put n, calculate, we will get the mean. After finding the mean, you can prepare the second column, prepare the row or column, anyone. So I have to write row, calculate the second row, which is x minus x bar. Next row is x minus x bar bracket square. Do the sum of last row, write the formula, put up the numbers and calculate. So you will get the standard deviation. That is, what is the purpose here? To calculate this one, just remember the steps. That is very important. So now this is the formula for the coefficient of variation. Coefficient of variation is standard deviation upon mod of mean into 100. Standard deviation is 2.58 here, mean is 5 into 100, calculate it, we will get the answer here 51.6. So this is the last answer. So now we will consider another example for different data. So what is the change here? We have to given the group frequency distribution. We have to given the group frequency distribution. So to group frequency distribution, what is the change? We should take the mid values. We should take the mid values here. So to solve the, if you observe both the problems carefully, in previous problem we have to given discrete data x1 to xn, but in this problem we have to given the group frequency distribution. So already I have to told you, to solve such a problem we use the same formula, but we consider here mid value of each class. So now I have to write here every observation column wise. So in first column I have to written the weight, which is we have to given in the problem. Remember in previous slide we have to given the observations. We have to given the first column as well as the second column, and the question is to find the standard deviation and the coefficient of variation. So now in weight in kg is given, classes are 30 to 40, 40 to 50, 50 to 60 and so on, last is 70 to 80. Frequency is also given 3, 5, 12, 20, 10 respectively. So my suggestion is first you have to should write the formula. What is the formula for the standard deviation? So standard deviation is the positive square root of summation of f times xi minus x bar bracket square total divided by summation of f. So for that first I have to require the mean, and the formula for mean for frequency distribution is x bar equals to summation of fx upon summation of f. So for that we required summation f. So have to do the addition of all the frequencies. In second column at the end I have to return summation of f, which is 50, which is the addition of all the frequencies. In third column, look at the third column, mid values. We have to calculate the mid value of each and every class. So what is the formula to calculate the mid value of each and every class? Lower limit plus upper limit divided by 2. So 30 plus 40 is 70. The half of 70 is 35. Same do for the next one. 40 plus 50, next class is 40 to 50, their addition is 90 and its half is 45. So easily you can calculate the mid value of each and every. So mid value of first class is 35, for next class is 45, next class 55, next one 65, next one is 75. So all these are the mid values. So I denote these mid values by x. These are our x1, x2, xn and corresponding frequencies are f1, f2, fn. Next, to calculate the mean, we required product f into x. So calculate the next column f into x. F into x means multiplication of the second and the third column. That is multiplication of the numbers, corresponding numbers of the second and the third column. Output will be the next, that is fourth column. So 3 into 35 gives 105, 4 into 45 gives 225, 12 into 55 gives 660 and continue in this way. 10 into 75 is 750. Again do the sum of these products. 105 plus 225 plus 660 plus 1300 plus 750 and the sum is here. I have to write 3040. So this is a sum. So then calculate x bar. What is x bar? X bar is summation of fx upon sum of f, which is same as x bar equals to put sum of fx, which is 3040 upon sum f is 50, and if you do this division, the answer is 60.8 is the mean. Okay, so after calculating mean, we calculate the next column. See the second next column, that is x minus x bar. Here x bar is 60.8, that is x minus 60.8. That is from each x we have to calculate, we have to subtract it 60.8, that is mean. So see the column third, in third column we have to given x and from each member, from each value of x we have to subtract 60.8. So 35.60.8, 35 minus 60.8, output is minus 25.8. I have to write this in the fifth column. Then 45 minus 60.8, answer is minus 12.8 and continue in this way. So write all the differences, that is subtract 60.8 from each value, from each mid value of the class. See the next table. The next column is, in the table next column is f into x minus x bar bracket square. F into x minus x bar bracket square. So I have to skip one step here. So you write here, first square the number x minus x bar and then multiply by f. So how to obtain the first figure of this last column? So I take the number minus 25.8, square it and then multiply by frequency 3. That is minus 25.8 into minus 25.8 into 3. That is squaring the number in the fifth column, x minus x bar column, and then multiply by the frequency f. So we will get the output in the last column here. So 25.8, its square into 3, the output or the multiplication is 19,900, sorry, 199.92, 196.92. Similarly, do all these calculations. So again I will explain you how to obtain the next column. So next number is minus 15.8. First take its square and then multiply by its frequency, that is 5. So output is 1248.2. Similarly do the next one. Then after finding all these numbers, add them. After adding this, the output is summation of f times x minus x bar bracket square is 6018, 1 and 18. Okay. So now write the formula for standard deviation. In the last cell I have to written the formula SD equals to summation of f into xi minus x bar square upon summation f is equals to root of 6018, put the value upon 50, calculate by using calci. So the answer is 10.97. So this is our last answer, standard deviation. So if you know the standard deviation, you can calculate CB also. So let us summarize our today's lecture. In today's lecture, we have studied various concepts of measures of dispersion. If we calculate simply mean or the measure of central tendency, that is not sufficient for describe a given series or given data in some times. So for that purpose we need a dispersion. Dispersion actually measures the degree of variability, how much data is scattered around the mean. We can observe or we can study by using the dispersion. So dispersion is nothing but the variation of the values of the variable from their mean is called the dispersion. So we know that there are different types of dispersion, absolute measure of dispersion and the relative measure of dispersion. There are 4 types of absolute measure of dispersion and 4 types of relative measure of dispersion. Absolute measure of dispersion like range, standard deviation, quartile deviation and variance. This is also one absolute measure of dispersion. But sometimes absolute measure of dispersion is always have a unit similar as the given data, and suppose I have to compare the 2 different data, then in that case I can't apply the absolute measure of dispersion. So in that case we have to use relative measure of dispersion. In relative measure of dispersion it is a unitless, it has a no unit, so it is useful in that case for the comparison. So among these dispersions, absolute and the relative, we have studied 2 types of relative and 2 types of absolute measure of dispersion. Among these, the first one is the range and the standard deviation. These are 2 absolute measure of dispersion, and coefficient of range and coefficient of variance are the 2 types of relative measure of dispersion. The range is nothing but the a simplest definition, the lowest observation highest observation minus lowest observation, that is L minus S. L is the largest observation minus the smallest observation of the given range. Again, if data is described in different form, according to you should give the write the lowest and the highest observation. That is especially in case of data is given inclusive type of frequency distribution. So in that case we have to calculate the largest and smallest. We have to write the largest and smallest by taking the class boundaries first. So also we have studied this range of coefficient of range, that is defined as the largest observation minus smallest observation divided by largest observation plus the smallest observation. So it has no unit actually. Next we have to discuss about what is meant by standard deviation, what are its formulae for discrete and frequency distribution. So standard deviation, we write first formula here. So you can easily write the definition in terms of word also. So standard deviation for discrete data x1, x2 up to xn is defined as square root of summation of x minus x bar bracket square upon n. And if I have to given in terms of frequency distribution, that is x1, x2, xn are the frequencies and are the observations, and corresponding frequencies are f1, f2 up to fn. Then the standard deviation is defined as square root of summation of fi in bracket xi minus x bar bracket square upon summation of f. Okay. And in case of suppose we have to given the class group frequency distribution, in that case we consider xi as a mid value of the ith class, but the formula remains the same to calculate the standard deviation. Also we have discussed about variance. The variance is defined as the square of the standard deviation, and we have to calculate coefficient of variation also. The coefficient of variation is defined as the standard deviation upon absolute value of the mean into 100. This is a relative measure of dispersion. So now in next lecture we will study how to find the standard deviation by deviation method, standard deviation by step deviation method, as well as the standard deviation by combined groups and examples. Because if you observe the last example, now in last example we directly find the standard deviation. So here because of the figures, if the figures are large, in that case the calculation becomes complicated. It takes too much time to calculate the numbers and so on. But if you can use the standard, you can use the deviation method and the step deviation method to reduce our calculations, that are also known as the change of scale method or the change of origin method. So, okay. So in next lecture we will see all these new methods or the new variations in next lecture. Goodbye.